5t to 4, okay? Plus partial z, partial y, what do you have?
2.
2. X is the constant, y is the variable, so it's 2x. Then minus sine 1. Then multiply by dy dt. It's going to be 8t to 3. Okay? So this is pretty much it is. Its chain rule is just a matter of partial derivatives and regular derivatives. And then because I want to have a function of z completely depending on t, I also want the derivative to be in terms of t as well. All right? So I'm going to change everything into variable t. So this is going to be exactly a relation between z and t. How do we do that? We just substitute t to 5 and 2t to 4 into this equation, and that's all. So it's going to be 2 cosine 2t to 4. Maybe we can combine all the numbers and coefficients in front. So it's going to be 10t to 4. Then minus 16. I have x to be t to 5 and I have a t to 3, so it's going to be t to 8. And sine 2t to 4. Okay, so that is going to be our final answer. In the end, I want to see essentially z prime of t is equal to a function of t. Okay, so this is a very easy application of the chain rule in the easiest form. Michael?
Why can't we just substitute the x and y?
Exactly, that's another thing I want to mention. I use the chain rule here to compute the derivative of z with respect to t. But there's another route to go compute this derivative. And Michael suggested, what if I substitute x and y by t directly in the very beginning instead of substitute them in the very end? So if I'm substituting these two functions back into this formula, I'm getting a function with respect to t. Are you with me? So let's do that. So if I substitute x equals t to 5, y equals 2t to 4, I'm getting z with respect to t is equal to 2t to 5 cosine 2t to 4. All right? Pretty easy single variable calculus appears right here. So if I'm computing z prime of t, I'm just using a product rule for this function. So we can all work together. What do you get? 2 times 5t to 4, so derivative of this component cosine 2t to 4, then plus 2t to 5 multiplied by minus sine 2t to 4, then multiply the derivative, the inside, you're getting a 8t to 3, all right? So if you simplify all these two terms, you're getting exactly 10t to 4 cosine 2t to 4 minus 2, 8, 16 t to 8 sine 2t to 4. Okay? They're exactly the same. You can either do the substitution in the very beginning, you don't even need to use the chain rule anymore. Or you can use the chain rule and then substitute the only variable t in the end. Both of these two methods will work, and they will arrive at the same answer as well. Okay? As I said, that chain rule is really the simplest form possible. So there's not much thing to happen over there. And I just want to mention the difference between partial and the regular derivative. You can also practice by looking at a different example. So these kind of examples, everyone get? Okay. So next, I wanted to simplify this, make this slightly more general. Okay. So let's say if I have one dependent variable W, I have x, y, and z, 3 intermediate variables. All of them are depending on t. Okay, all of them are depending on t. I can still eliminate the intermediate variables x, y, and z to get a function of w with respect to t. Okay, so the chain rule is very similar. So dw dt will be equal to, what do you imagine? If I'm computing dw over dt, I'm having a partial w, partial x, and then multiply by dx dt. So I have to take all the intermediate variables into account, all right? Plus partial w, partial y, dy, dt. And then plus partial w, partial z, dz, dt. Okay? In fact, not only you can generalize this to 3 intermediate variables, you can generalize this to any number of intermediate variables. In fact, this dependence is the format of the stock market. You can regard t as your time, right? So if you have the dependence of each single stock changing depending on t, you can get your whole performance of the stock market changing t, right? But how it is depending on some other variables, like the weather, like the oil price, it is going to be more complicated. So I wanted to practice against this formula. So if I have a function v is equal to x minus y divided by y plus z. So I have x is equal to t, y is equal to 5t, and z is equal to 4t. So I want to compute partial v, I'm sorry, compute dv dt. Okay, so let's see, Brent. Okay, so when I want to compute dv dt, or you want to compute dv dt, in fact, you can still go for 2 different methods, right? You can plug in x, y, z in terms of t into this fraction. Then you're getting a fraction with respect to t directly. So any derivative will just follow single variable calculus. Or you can do this chain rule. You can do this chain rule by using that formula. Which one do you prefer?
I'm working out the equation right now, but if we want, we can do the chain rule.
You want to use the chain rule? Good.
Yeah.
So what do you have?
So the derivative, sorry, so the partial derivative of v with respect to
Partial
x, and then dx dt. And partial of v is y, dt, and then partial v, partial of z,
Partial v, partial z,
and dz dt.
dz, dt. So we all agree on my choice of partial and regular derivative, all right? Okay, so next, let's do some actual computation. Partial v, partial x.
Yes. So that would just be negative y over y plus z, right?
So when I'm computing partial derivative for v with respect to x, y and z are both constant. Right? So this is essentially equal to y plus z multiplied by 1x. So if you want to write down this in a simpler form to see how these constants are matching here. So let's write down this guy. Now people do. So v is equal to 1 over y plus z times x minus y divided by y plus z. Will that help you?
Yes.
X is the only variable here. All the other terms are constant.
Also,
Right.
it'd be 1 minus.
1 minus, yeah, exactly. 1 over y plus z. Again, everybody, you really need to do some more practice. If you're smooth about this, you can immediately see, okay, y, z are constant, so this is going to be just a coefficient for x. If you cannot see it directly, you can modify your function slightly to stress x is the only variable here. Okay? So this is the derivative with respect to x multiplied by dx dt, which is just 1. So partial v, partial y requires a slightly more computation here. Right? So y is the variable, x and z are the constant. What do you have?
Would that be x minus 1 over y plus z?
But I have the variable in the denominator as well.
Oh,
Right? So I have to use a quotient rule for this guy.
okay.
Right? So essentially, when I'm taking the derivative with respect to y, I have to see whether the numerator and the denominator are both functions of y. Are you with me? If they're both functions of y, I have to use the format of, this is essentially equal to f of y divided by g of y. All the other terms are just constant. So if I'm computing derivative with respect to y, I have to use the chain rule, under quotient rule here, right? What do you have?
That'd be negative
Y plus
z
z squared, and then f prime,
Yeah, so that'd be -1.
-1 multiplied by
Y plus z.
y plus z, and minus g prime,
Which would be x minus y times 1, right?
g prime is going to be, yeah, x minus y times
1.
g prime is just
Just 1.
just 1. Okay, so this is what we have. And then dy dt,
And that would be 5.
that will be 5, okay. And partial v, partial z, still I have to look at this fraction and see numerator and denominator, the dependence on the variable z. Again, all the other terms are constant. You can simply say this is a number. This is also a number. So this is like a number over z plus a number. How do you take the derivative?
But wouldn't that be negative
Minus
x
y plus z to
squared?
squared. But all the constant will
X minus y.
stay, right? And dz over dt is
4.
4. Okay, that with me? So again, if you're not sure of taking the partial derivatives, work on them separately. You compute what partial v partial y is, and then you plug in. Okay? Maybe after the whole computation, you might prefer the other method. Okay, so let's compute all the things together, and we can simultaneously plug in t into this formula, right? So y is equal to 5t, z is equal to 4t, so I'm getting 1 over 90, all right? 1 over 90. So next one, I'm having, so this whole thing is equal to, so it's minus y minus z minus x plus y, all right? So if I break the parentheses, so y get canceled. I have minus z minus x, right? So it's going to be minus z minus x divided by y plus z squared. So we want to be careful. So let's do this separately and multiply by 5, right? Multiply by 5. And very last one is minus 4x minus y divided by y plus z squared. Okay? And very end, we're going to plug in our variable t here. So it's going to be 1 over 9t minus, so z x, so minus z minus x, you got a minus
Negative
5t. And then I have a 5, so it's going to be minus 25t divided by z plus y. I got a 9t right here. Right, 9t squared, so it's going to be 81t squared. And then minus 4x minus y is going to be minus 3t. Okay, so it's minus 3t divided by y plus z squared is still 81t squared. So if I simplify the whole thing, let's see what I have. I have 1 over 9t minus 25 over 81t, then plus, so it's 327, so it's 427t, okay? Hopefully I'm not making any mistake. In fact, all these terms can be combined together, right? All these terms can be combined together. The common factor, you can actually find 81t to be the common denominator. Am I right? Yeah. So if I have 81t here, so the first one is going to be 9, second one is 20, minus 25, plus 1 plus 4. So it's going to be 21 minus 24, 5, so it's minus 4 divided by 81. Okay? Hopefully I'm getting the correct answer.
That's supposed to be minus 4t.
X minus y, you are negative 3t, and x minus y should be 14.
Which one? This part?
Yeah.
So numerator there.
It's supposed to be negative 14.
Instead of negative 3.
Negative 4. So x minus y, I'm having a minus 4. Yeah, exactly. Thank you. So this is minus 4. That will change my answer right here to
16 over 80.
16 over 81. So 16 over 81. So in the end, I have 9 minus 25 plus 16. Everything got canceled in the end.
Yeah, zero.
It's going to be equal to 0. Okay, only if we knew the answer already.
And the substitution, it actually doesn't take like a second. I don't know.
Okay, so since this is Michael's favorite way, let's do this. From the other master and check our answer. Because this chain rule is taking quite some computation here, so if you do not feel very confident, this is indeed the correct answer. Let's see what do we have. V is equal to x minus y is minus 40 divided by
90.
90. So in the end, it's going to be minus 4 divided by 9.
0.
So the constant is the derivative has to be equal to 0. Right? So the only point for correcting this problem is to get used of our chain rule here. Okay? Questions? Okay, if not, let's practice more general chain rules here. Like I said, in the very beginning, we have 2 intermediate variables, and then you've got 2 new variables coming. That's how that chain rule works. So if I have a function z is equal to fxy, x is a new function involving s and t, and y is also a function involving s and t. Now, if I eliminate the intermediate variable, I'm supposed to have a function of z with respect to t and s. Therefore, I will be able to compute these 2 partial derivatives.